Hello everyone. So in this particular video, we will try to discuss about um, the various psychometric process. So this particular video is very important as it covers all the psychometric process. The understanding of this process becomes important for the problem specific. Okay. So there are totally majorly four processes. One is sensible heating. The second one is sensible cooling. One is humidification and other is dehumidification. So all these four processes are treated as a psychometric process. So these psychometric process can take place individually. I mean to say it could be sensible heating alone, it could be sensible cooling alone, or it could be mixing of these two. I mean to say it could be humidification and cooling, it could be dehumidification and heating, like all those processes are there. We shall try to discuss one by one. So the first process what you are discussing is the sensible heating. So heating or cooling of air without the change in the moisture content. So this particular sentence is very important. So when you are trying to heat or cool the air simultaneously, if it is a sensible heating, you are trying to heat it. If it is sensible cooling, you are trying to cool it. So if you are trying to heat it, but the condition is there should be no change in the moisture content. So the change in the moisture content, that means if there is no change in the moisture content, the value of omega will not change. Correct? If the value of omega, what is omega? Omega is specific humidity. So keeping specific humidity constant, if you are trying to heat or cool the substance, then it is known as sensible heating or sensible cooling process, guys. Okay, so this is about the sensible heating or cooling process. Okay, now the specific humidity, that's what I explained, thus the specific humidity remains constant during this particular process. Now how it is done? Air is passed over either a heating coil or a cooling coil. Like if it is a heating coil like this, so whatever the air is incoming here will be heated to a higher temperature. That means if the temperature of the air is T1 here and the temperature of the air is T2 here, if this is a heating coil, what happens? Your T2 temperature would be on the higher side. Similarly, when you are trying to do it with a cooling coil, so this is a cooling coil, guys. So in the cooling coil, if this is the temperature T1, incoming temperature T1, and this is the outgoing temperature T2, okay, so your T1 would be the higher value because it is cooling from T1 to T2. Okay, so all this heating process and cooling process will take place keeping the omega value to be constant. So this is very important. Once your omega value is constant, then only it is known as the sensible heating processes. So how do you calculate the heat supplied or heat rejected in this particular process? It is given by mass of air. I mean total, here it is total mt into cpt into T2 minus T1. You can split this up into mass of air and mass of the vapor. So mass of vapor, here actually it must be mass of vapor, is it? So this mass of vapor can be extracted from here. So what does mass of vapor indicate? Mass of vapor is equals to omega into mass of air, is it? So that is what here is written here. You can substitute all the Cp values and this particular equation you can get. So either you can use this equation, either you can use this equation or this equation to calculate the heat exchange in the sensible heating and cooling processes. Okay. So this is how it looks. This is what I was explaining. So this is the heating coil and this is the cooling coil. Here the cold air is converted into hot air by increasing its temperature, and here the warm air is being converted into cold air by decreasing its temperature. So this is how a sensible heating process looks like in a psychometric chart. So remember, these are psychometric charts representation. If it is of such order, like if it is given in such an order, then you have to assume that this is represented on a psychometric chart. Okay. So in a psychometric chart, what happens? Your sensible heating process will be a line on the x-axis from 1 to 2 like this. Okay. In the reverse order, in the negative x-axis, it will be a cooling process. That means if I try to draw some axis like this, so your sensible heating process I can represent in this particular axis. So this is known as the sensible heating process, correct? This is sensible heating. Now, how do you represent the sensible cooling process? So, sensible cooling process can be represented by on the negative side of the x-axis. You can represent the sensible cooling process on the negative side. That means it is going from 1 to 2 in the negative direction. This is how the sensible cooling process is being represented where on the psychometric chart. Okay. So, next process, this is very important, latent heat process. So, if you remember the definition of the latent heat, what does it apply? Latent heat is that heat where you are giving to a substance, but it is for only the phase change, correct? So, when the entire temperature, entire heat energy, whatever you are giving to the system, if it is utilizing for changing its phase, then it is known as a latent heat, correct? Now, but the condition is the temperature of this particular substance must be constant. So, similarly here also humidification, that means you are adding up the moisture content. Dehumidification, in the sense you are removing the moisture content from the air. All this process can involve change in specific humidity. Definitely you are changing the moisture content, in the sense you are changing the specific humidity of that particular substance, but subjected to the condition that the dry bulb temperature remains constant. So, if you can observe this particular process here. So, this process from 1 to 2 in which there is a constant dry bulb temperature. This is a T degree Celsius something, right? So, all the state 1 and state 2 is of the same temperature. That means you are keeping the dry bulb temperature to be constant. Okay, so that is humidification and dehumidification process. Similarly, you can go with these equations to calculate the values of the heat exchange during this humidification process. So, humidification and dehumidification process are cumulatively called as the latent heat processes. Okay. Now, so remember this particular thing, latent heat of vaporization at 0 degree Celsius is 2500 kilojoules per kg. Note that value, it would be helpful in the problems. Okay. Now, this is the total heat process. Now, what is the total heat process? Now, if you try to observe this particular graph here, so as I told you, on the positive side of the x-axis, you can represent the sensible heating process. On the negative side of the x-axis, you can represent the sensible cooling process. On positive side of the y-axis, you can represent the humidification, which is a latent heat process. And in the negative side of the y-axis, you can indicate the dehumidification, which is again a latent heat process. Now, you can, so from this figure, from O to A, if the process is going like this, okay. Now, assume the process is going like this. So, this is state 1 and this is state 2 and this is the initial state and this is the final state. So, it is nothing but OA. That means what it is? It is sensible heating process. Okay. Now, similarly, in if in the psychometric chart, if it is of such order, here is my state 1 and here is the state 2. So, it is going in the negative direction of the y-axis. So, what happens? It is OB, correct? So, OB in the sense it is sensible cooling process. So, in the psychometric chart, again, if some process is going in this particular direction, that means here is my state 1 and here is my state 2. So, this is my initial state and this is my final state. So, what happens? So, it represents in the OC, correct? OC. So, this is OC. So, OC in the sense it is a humidification process. Similarly, OD would be the dehumidification process. So, all these 4 processes are the basic processes. Now, the combination of these processes can also occur, right? For example, if in some problems, if it is going in such a fashion, okay, it is going from state 1 here and state 2 here. So, it is going in the direction of OE, correct? So, OE in the sense it is heating as well as humidification. That means, if it is going in such a direction, so it is sensible heating plus humidification. That is what? So, written here OE. Okay. Suppose in the process, if it is in the psychometric chart, if it is going in such a way, so here is my state 1 and here is my state 2. That means it is coming in this way. What should the process be? The process should be the dehumidification and sensible cooling. That means cooling and dehumidification. So, it is represented by OF here. So, OF is what? Cooling and dehumidification, guys. So, this is how the various processes in the psychometric charts can be analyzed. Okay, all you need to remember is this particular figure here. So, this particular figure is very important. and to understand this particular thing. So what is a positive side of the x-axis? It is sensible heating. Negative side of x-axis is sensible cooling. Positive of y is humidification, and negative of y is dehumidification process. So in this particular what you can say, the total process, you are supposed to there will be two heats in fact. Okay, so this process is what it is, sensible heating and humidification, correct? So in this particular thing, what happens, there will be two heats. That means there will be a sensible heat as well as the latent heat in this process. So the sensible heat is given by, what is sensible heat? Where the omega is constant. If omega is constant, it is represented by this particular line. If it is this line, then it is H3 minus H1, correct? Now, what is latent heat? Latent heat is something where the temperature remains constant. That means it is represented by this particular line. Then it is H2 minus H3. Then the total heat occurred from state 1 to state 2 is a summation of sensible heat plus latent heat. So it is, if you add both these two heats, then only you will get the total heat which is interacted from state 1 to state 2. That's why when it is involving with two different heats, there is a factor to describe the amount of influence of these two heats. It is known as the sensible heat factor. So what is sensible heat factor? It is a ratio of sensible heat to total heat. So in the total heat, how much quantity of sensible heat you are having. So similarly, substitute the value of sensible heat and the total heat, you will get the sensible heat factor. So this is all about the various process in this psychometric charts. So you have to be strong regarding this particular process, so that all your things would be very easy. Okay, problem solving.